Hi Year 11. I hope you all had a fantastic holiday. I know we're not here over the next few days because of the virus, but I thought it would be an excellent opportunity for us to learn from our mock examination results. You'll get the results back hopefully next week when you return, and for us to reflect on areas in which we can improve. Now, one of the topics that we definitely need to work on is vectors. Specifically, how you work out or how you show that 3 points lie on a straight line when you're looking at the vector geometry kind of questions. So this is a very typical exam question. We have a parallelogram, OABC. O to A is the vector A and O to B is the vector B. That's given in the question. Don't forget, it's really important to remember that it's the direction of the vector that's really important. So A goes this way, B goes that way. M is the midpoint of the vector AC, so M lies in the middle. And we're given this ratio, AN to NB is 1 to 2. Now, before we do anything else, I'm going to put this straight on here, just so we remember. A to N is 1, N to B is 2. So that means that overall, out of the whole thing, it would be out of 3, okay? And we'll need that later. Now, I need to prove that ONM, so if I put that on here, I need to prove this dotted red line is straight, okay? To do that, you have to show that two of the vectors, so ON and OM, or NM, are scalar multiples of one another. That means that they have the same vector, just multiplied by a different constant. For example, let's do ON and let's do OM. Now, if I show that these are the same vector, or going in the same direction, that will allow me to show that they're on a straight line because they start at the same point. So let's do ON. To get from O to N, you can't just go that way because we only know A's and B's. Okay, but how I get there is I can go O to A and A to N. Or I can go OB and BN. Doesn't matter, you can go either direction. Let's go O to A and then A to N. Now the first bit's easy. OA is very, very simple. O to A is just A, it's given in the question. Now A to N requires just a little bit of thinking. This is where some of you are going slightly wrong. A to N is 1 out of the 3 lots, isn't it? Because there's 1 here and 2 here, meaning that there's 3 in total. So A to N is 1/3 of this whole vector here, of the vector A to B. So we now need to work out the vector A to B. A to B is very simple. We're going from here to here. You have to come this way and then that way because we can only work in terms of A's and B's. So if I'm going this way then this way, I go minus A plus B. Do minus A plus B. That is another very common mistake. A lot of you are writing A plus B in here. Some of you are writing A minus B. What I find helpful is the fact that I'm going from A to B, I'm going to put my finger here and I'm going to work out, I've got to go this way, right? Do this in your exam. Trace with your finger going this way, that's minus A, and then going this way, plus B. So all I now need to do is expand the brackets and rearrange. I get A minus 1/3 A plus 1/3 B. Which A minus 1/3 A is 2/3 A, and I get 1/3 B. Okay, so O to N is 2/3 A plus 1/3 B. I'm going to write that down up here and rub it out so I have some more space. If you need to go back, obviously you can do, just rewind the video. So 2/3 A plus 1/3 B. Now, I'm going to find O to M, and this one's a lot easier. O to M You could go OB, BC, and CM if you wanted to. A lot more complicated. The easiest way is to go O to A, and then go A to M. O to A, again, is easy. It's A. And A to M is a half of A to C. 1/2 AC, because M is in the midpoint. If M's in the midpoint, chops it in half. This is 1/2 of the whole thing. So A to M is a half of A to C. Now, A to C is very, very easy because it is a parallelogram. Yeah, OABC is a parallelogram. That means that both sides are, or the opposite sides are parallel and the same length. That means that A to C, this vector there, is the same as this vector here. It is B, the whole thing. And therefore, I have A plus 1/2 B. So I've got my two vectors. I've got this one and this one. And what I now need to do is show that one is a scalar multiple of another. If I'm able to do that, it means that they are parallel, okay? So let's take this to start with. Let's take 2/3 A plus 1/3 B. So ON is 2/3 A plus 1/3 B. Now, I'm going to take a third outside the brackets because you can see it's common to both of them. If you're comparing this and this, you need to look at what you can do and what you can factorize so that they become the same, okay? Or at least one's a scalar multiple of another. So if I take 1/3 outside the brackets to start with, you'd have 2A plus B. And now we're getting pretty close. You can see this is 2A plus B, and this is A plus 1/2 B. So all I now need to do is take 2 outside the brackets as well. You can tell that because you have 2A and then just 1A here. So if I take 2 outside the brackets, 2/3, I would be left with A plus 1/2 B. Now, of course, you don't need to do this middle step here. If you can spot, you have 2/3 straight away. Just take 2/3 straight outside the brackets. Okay, you can see the coefficient of A is 2/3, and the coefficient of A is 1. So I could just take 2/3 outside the brackets and do it in one go. Bit easier to do it in 2 steps, okay? But it doesn't matter. Now, finally, you can see that OM is A plus 1/2 B, and ON is some number, doesn't really matter what it is, and it's A plus 1/2 B. Therefore, they are scalar multiples of one another. So you write down ON and OM are scalar multiples. They share the common point O, and therefore ONM is a straight line.